Hello everyone, welcome to my channel. So let us start with today's topic, that is graph basics. So what is a graph? Graph consists of two components. One is vertices, the other is edges. Let me take an example. Every node is called an vertex. A is a node, B is a node, D is a node, C is also node. And the line joining two vertices is called an edge. Now that we know what is a vertex and what is an edge, let me give a formal definition of graph. A graph is an ordered pair defined as G is equals to V comma E. It's an ordered pair, which means that we cannot interchange this V and E. Where V is the vertex set of G and E is the edge set of G. The next topic is simple graph. So let me take an example first. Vertices A, B, C, D, and these are the edges. This is a simple graph. How do we say this is a simple graph? It has the following properties. It has no self loops. For example, none of the vertices have a self loop from itself. This is an edge, self loop edge, but it's not present. Does not have multi edges. Between two vertices, which means A and B don't have more than one edge between them. And the last is, these simple graphs are undirected. That is, none of the edges are directing to any other vertex. So this is a simple graph. Now let's look into complete graph. A graph G in which every pair of vertices are joined or connected. For example, this is not a complete graph because it doesn't have an edge between AC, CD and AD. Let me give you another example for complete graph. The following graph is a complete graph because there is an edge between every two vertices in this graph. For example, take B and E, B and D, D and A. Everything is connected, so it's a complete graph. So whenever you study graphs, there is something called cardinality. So what is cardinality? Cardinality is just amount, or you can just say number. It's like a count of something is called cardinality. For for example, the cardinality of A, number of vertices it's connected, 1, 2, 3 and 4. So let's see order. What is order? Number of vertices of graph G, or we can say cardinality V of G is called an order and is denoted by size. This is also similar to order, but this is number of edges. Or similar to the above, cardinality. E. This is denoted by E of G. Let's see what is adjacent. Consider the following example. This is U, UV are the edges, vertices, and there's an edge connecting both. This means that U is adjacent to V. That is, if UV belong to an edge E, implies that U and V are adjacent. Vertices. Similarly, consider E and E dash to be two edges with common vertex. Then E and E dash are adjacent edges. For example, ABC are three vertices. Edges E1 and E2 are said to be adjacent because they have a common vertex B. In this, E1 and E2 are adjacent edges. Similarly, A and B are adjacent vertices. B and C are adjacent. Consider the above example. U and V are two vertices connected by an edge, say E. And vertices. In the above graph, U and V are end vertices if U, V is an edge. And we say E is incident with U and V. The next topic is neighbor. Take the following example. U and V are two vertices connected by an edge E. Now, if UV is an edge in G, then we say U is the neighbor of V, or V is the neighbor of U. Consider the following example. ABC are three vertices with E1 and E2 edges. In the following example, the neighbors of C are A and B. The neighbor of B is only C. The neighbor of A is only C. Now let's move on to neighborhood. Neighborhood is nothing but set of all neighbors of U and is denoted by the letter N, G of U, or simply N of U. For example, A, B, C are three vertices connected by edges E1 and E2. In this, neighborhood of A is B, neighborhood of B is both B and C, and neighborhood of C is just B. Let's move on to the next topic, which is degree. What is a degree? Degree is just number of neighbors of U, or we can say neighborhood of a vertex. Here U is a vertex, can be any vertex. Degree is neighborhood of a vertex. So number we can use better term is set of all neighbors of U or neighborhood vertex is called degree and is denoted by dg of U, or in simpler term just d of U, where U is a vertex. Let's move on. Before moving on, let's look into an example. ABC are three vertices. Degree of A, number of vertices, its neighbor, it's C and B, so it's 2. Similarly for B, it's A and C, so it's 2. Degree of C, neighbors of C, it's A and B, so it's again 2. Minimum degree. This is nothing but the minimum of vertex degree of G, that is smallest. Degree of G. It is denoted by G. Now, maximum degree, similar to minimum degree, this is the maximum value of all the vertex degrees. G, largest. And is represented by delta G. Let me give you an example. consider the following vertices A, B, C, D, E and F. Let us see the degree of each vertex. Degree of A is 1, 2. Degree of B is 3. Degree of C is 1, 2, 3, 4 and 5. Degree of E is 1, 2. Degree of D is 1. Similarly, degree of F is 1. In this example, the maximum degree would be C. C would have the maximum degree, and the minimum degree is both D and F. Thank you for watching. Please subscribe and like. Thank you.